Hello, class. Um, Today we are going to be seeing the right angle triangle. Okay, if you recall from last time, we started talking about uh, plane shapes, to which we spoke about polygons. Now, I told you we are going to handle the right angle triangle, specially in the subsequent term, which is third term. Okay, now the definition is right here. It says a right angle triangle is a triangle which has one of its angles as 90 degrees. Once you have a triangle and one of the angles is 90 degrees, you have a right angle triangle. Okay, now a right angle triangle, because of its peculiarity, we name its sides. We have what we call the hypotenuse. Now this hypotenuse is always directly opposite the right angle, directly opposite, if you can see. Now the hypotenuse is always the longest side. It's very long. In a right angle triangle, the longest side is the hypotenuse, okay, and it's always opposite your right angle. When we say right angle, we're talking about angle 90 degrees, okay. And then the other sides of the right angle triangle are called opposite and adjacent. Subsequently, when we go further in our studies, you understand why it is named opposite and adjacent. But the opposite and adjacent is not really fixed. It depends on which angle you are referencing. That will give you which will be the opposite and which will be the hypotenuse. Which will be the adjacent. But the hypotenuse is always the longest side, no matter the angle of reference. Okay, now, sorry about that. We'll see the area of a triangle. Now, the area of a triangle is given as half base times height. You know this from primary school. Now, example number 1. Find the area of a right angle triangle with base 6 cm and height 11 cm. Now, your base there is 6 cm and your height is 11. You substitute into your formula and then you evaluate. You have 33 cm square. Now, area is always in the square of the unit. If you write 33 cm, it is wrong. It has to be 33 cm square. Example number 2 says, find the base of a triangle whose height is 12.5 cm and area is 50 cm. Now, the area was given, the height was given, but the base wasn't given. You have to find it. When you substitute these values into the equation, so you have b times 12.5 times 1. You have 12.5b and then over 2. Now, I taught you from last time, whenever you are faced with this, you cross multiply. Okay? You cross multiply. You have 2 times 50, then 12.5b times 1. So that at the end of the day, you have 100 is equals to 12.5b. You divide both sides by the coefficient of your unknown, and then you have your answer as the base is equals to 8 cm. It's as simple as that. Now, this is not the area, this is just revision. Now, we'll go to Pythagoras theorem. Now, this is very important and you should be very attentive to this lesson. The Pythagoras theorem states that in every right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That means this hypotenuse is the longest side of a triangle. From our triangle ABC, if you notice, C is the longest side, then we have A and B as other sides. Now, based on the Pythagoras theorem, the square of C is equal to the sum of the squares of B and A. Now, if I square B square. If I square, I have A square. So you see, that's why I wrote, by Pythagoras, C square is equals to A square plus B square. Okay, that means in every right angle triangle, whenever you want to find any side, you should use this formula that the square of the hypotenuse is equal to the sum of the squares of both sides. Okay. Now, example number 1. Find the length of the side marked x. Oh, sorry, I'm supposed to. This is a right angle triangle. I forgot to put the right angle triangle sign. Now find the length of the side marked x. Okay. Now if you notice, the side marked x is the hypotenuse. Therefore, so x is the hypotenuse. Therefore, x squared will be equal to 4 cm squared plus 5 cm squared. Okay. When you sum it up, you have 16 cm squared plus 25 cm squared. When you sum it, you have 49 cm squared. But you are interested in finding x, not x squared. So you take square root of both sides and you are left with x is equals to 7 cm. Okay. Now example number 2. Now in example number 2, sometimes they can give you mix. This is what we call a mixed shape, where you have a lot of triangles, and then you should try and isolate. Your power to isolate, your thought to isolate will make it easier for you to solve this kind of questions. Don't take it as a whole. Just take triangle by triangle. Okay. Now, example number 2 says, find the lettered side in the figure below. Find the lettered side. We have A, B, C. Okay. Now, A. If you take triangle ABC, forget about D. The triangle ABC is a right angle triangle, and that portion, this Y is the hypotenuse in that triangle ABC. So by our Pythagoras, y square, if you come down here, y square is equals to 5 square plus 12 square. So 5 square plus 12 square is 169. You take square root of both sides and you have 13 cm. Okay, but we have another figure we have to find. That's Z. Okay, and if you notice, now let's go to the next plane. From triangle BCD, this triangle BCD, this down one here, the triangle that is down below, BCD, you know, triangle BCD is also a right angle triangle, and the 90 degrees is at D. If you notice, the 90 degrees is at the point D. Now, our hypotenuse there is y still. Okay, so by Pythagoras, y square will be equals to c square plus c square. Now, but y is equals to 13 cm. Okay, so you substitute 13 for y. When we substitute, we have 13 square is equals to c square plus z square. You collect like terms because z square and plus 6 square are on the same plane, but you collect like terms. So you shift this c square to the other side, and instead of just 6 square, it becomes minus 6 square because it is crossing the equality sign. Okay. Now, if you recall from last time still, I taught you difference of 2 square. Whenever you have this square minus that square, you can use difference of 2 square, or you can just go ahead and evaluate. So I did both of them in the planes. You can see on one side, on the left hand side, I used difference of 2 square, and then on the right hand side I use just the normal evaluation. Okay, anyhow you do it, you'll be left with 133 is equals to z square. Okay, so you take the square root of both sides, and then your z is equals to 11.53 cm. Okay, this topic is actually very simple, and please, if you have any confusion, you should drop it on the comments. Okay, I will be online. My network issue has been sorted out. It is very fine now. Okay, so last but not the least, we have what we call the Pythagoras triple. Now, from the understanding of Pythagoras theorem, each time you have any set of numbers that follow this Pythagoras rule, like the example we have here, when 3 numbers make up a perfect square, e.g. 3 square plus 4 square is equals to 5 square. That's true. So 3 square is 9, 4 square is 16. So 9 plus 16 is 25. So you can see 5 square is 25. Therefore, we'll say 3, 4, 5, all in bracket, is a Pythagoras triple. That's what we call it. Further examples, we have 8 square plus 6 square will give you 10 square. 8 square is 64, 6 square is 36. When you sum 64 and 36, you have 100, and 10 square is 100. So you can see, and that's all. Very simple topic. If you have any point of confusion, you should drop it on the comments. Drop it in the comment of the classroom, Google Classroom. Okay, you can even drop it on the YouTube channel. Okay, and please like and subscribe to this channel. Okay, and invite your friends to also like. Thank you.